All right. Hey, Block 7. I noticed somebody put this up here on the parking lot, number 21. So I can go through that with you because I don't really save time. I don't really get that many questions on homework. No reason for me to save time to go over it in class. That's why you hear me go nuts about concentric circles with the little time that we have here. So anyways, I put up my solution here. I saw one or two groups, actually both groups, third and fifth block, approached it kind of this way. And I'll talk about this in a second because this is sort of the way I think the book was hoping that you'd solve the problem based on what the material was like in the most recent section. So here, if this is an 80-degree angle right here, this is a two tangents angle here. It's going to intercept this arc here marked X, will be the smaller of the two arcs it intercepts, and then the remainder of the 360 degrees. So remember, two tangents, the two arcs together would sum to 360. Okay, but because the vertex is outside of the circle, we use the formula where there's subtraction. Okay, so you can do that way. I'll explain this way second. This is the way that I generally recommend people do problems, is that, hey, you can actually solve this one. You didn't need this most current section to figure this one out. So you could have done it this way. And I think, in fact, actually, you've looked at this already about a quadrilateral that gets formed with 2 points of tangency by two tangents here. Here, the central angle, we can figure that out very easily, actually. So anyways, a quadrilateral circumscribes about a circle having angles of 80, 90, 94, and 96. Find the measures of four non-overlapping arcs determined by the points of tangency. This is where my brain's always gone with it, with this particular problem. So it was really just the other explanations that I saw, third and fifth blocks, like, oh, this is the way the book wanted you to do it. So anyways, here, you got to think about what hints are hidden within the problems here. Points of tangency, okay? They said that out loud. Of course, by now, you should know what a circumscribed quadrilateral is. And that's a quadrilateral that's outside the circle, but each side is tangent to the circle. That would fit the definition of a circumscribed quadrilateral. So here I just have a generic one. I just drew it in randomly and tried to choose the angles appropriately. Like, here's my obtuse angle. Here's this looks like a right angle. This is a little obtuse. I actually think I drew this pretty well. But anyways, points of tangency, I got to tell you, so what do we know about points of tangency? Well, if I draw the radii in that are intersect those points of tangency, we know that tangents are perpendicular to radii that are drawn to the point of tangency at the outer ends of those radii here. So I have drawn in four quadrilaterals in this one, and by simply just introducing the four radii that you see pictured here. And what do I know about all this? Let's just maybe look at the green one here. Well, this is a quadrilateral, okay? In a quad, we have how many degrees? 360 degrees total, right? Because in a triangle, we got 180. In a quadrilateral, we have 360. In a pentagon, we have 540, right? Remember, we add 180 degrees each time. There's that formula, n minus 2 times 180, four-sided figure. That would be your n. 4 minus 2 is 2 times 180 is 360. So if I have this here, and I know this is a 94-degree angle, but I also know that these two are 90-degree angles because these are freaking tangents, right? They're tangents here. These are radii that I draw. That's definitely just the definition of radius. That's a radius here. So what's my central angle going to have to be then? Well, it's going to be 360 minus 94 minus 90 minus 90. You can do that calculation for sure. I totally think you can. So here we can think about it. Actually, maybe we'll add these all up. We'd be subtracting 274, right? Because 90 times 3 is 270, right? 9 times 3 is 227. So 274. If I take that away from 360, I get 86, okay? So my central angle here is 86 degrees, okay? That means this gonna measure that arc right here, and boom, I figured out my arc. Right here is gonna have to be 86 degrees as well. Okay, 86 degrees as well. And that's how I would solve this problem. That's how I would do it. I can maybe go through the other method really quickly here. So 90, 90, 90 gets us to 270. What's this gonna have to be? It's gonna have to be also 90. Okay, this is going to be a rectangle at the very least here. All these are congruent. Consecutive be. Let's see. I'm trying to think if I can prove it's a square. Not sure. I think it is a square though. Anyways, so this is going to be 90. Okay, all right. And what's the relationship here? 94, 86. 94, 86, 90, 90. What's the relationship? 80 So 80 plus 90 plus 90 would be 260. Take it away, we get a hundo right there, 80 and 100. So look, those angles are going to be supplementary, right? These are 180 of your 360 degrees. These are going to be 180 here. So what's this? 96, and this is going to be 84. Okay, so that's it. We get our problem. We get our answers here. This is 100. Okay, keeping it 100 right there. Purple, I don't have the purple color, so we'll do this here. This is 84. And there's your answers here. Okay, so I kind of go over that in much more detail on this slide. Try to break it down because I didn't see the number 21 that you wanted an explanation. So here's the video. Here's how the book was recommending you do it. I have it all laid out here. This is a two tangents angle to this circle, right? We're both tangent here if it's circumscribed. So this is an 80-degree angle, so we know that 80 degrees is going to equal 1/2 the difference between its intercepted arcs. So intercepted arc here, we might mark that y degrees. Intercepted arc here, that's x degrees. So 100 times by y minus x. Okay, y minus x here. What we also know about y, though, is that y is equal to 360 minus x. Okay, 360 minus x, because that's what's left over from the total amount of degrees in a circle once we subtract that x here. So here, we have this sort of independent and dependent relationship here that allows us to set something up. This here, y is dependent on how big that arc is. It's taking away x degrees from the 360. That means this is going to be the remainder. It's going to be 360 minus x here. So here, I could have just replaced y with 360 minus x, which is what I do, and I could have used the freaking formula that we have in the current lesson to actually solve, right? 80 degrees and have to equal 1/2 360 minus x, and I could have solved for x here. And what is x? Well, x is the first arc, okay? So I got 100 degrees there. 100 degrees there, I can repeat the whole process here. This is 100. I can do the same thing here too. This is where we're going to be. So this is going to be x. This is going to be 360 minus x, but now we're setting it equal to 90. Okay, half of that's equal to 90. Okay, solve it. You would have gotten 90 as your answer there. Would have gotten 86 as your answer there, and would have gotten 84 as your answer there. So similar steps can be followed by to find the remaining arc measures. You can totally do it here. Okay, so 2 different ways to solve the problem. Thank you for asking about number 21. Always, you can just leave questions on the Jamboard, the first slide here, and you're only going to get as far as your curiosity takes you. So please ask those questions away. Keep working hard. I will see you guys later. Bye.